So looking at this, oh, that's not too bad. Got, all right, so when you're looking for the amplitude, you just find the midline of the graph. Okay, so your midline is right here. There's not a vertical shift because it's always going to be symmetric. So we go up to, let's see, that's 1, 2, 3, 4 to get to 2. So every 2 is 1. So that goes up to 3, and it goes down to 3, which tells you it is basically centered on the x-axis. So your amplitude is what? 3. Okay. So then we look at the period, and it doesn't even show the whole thing, and that's okay. I can tell that it goes from, if we're starting here, goes from here, and then this would be halfway, right? And halfway through the period, we're at 2 pi, so what would the whole period be? 4 pi. Now, do you know for sure whether or not this is a cosine or a sine function? You don't, right? Because it looks like a less translated cosine function, but it really could be a sine, and it's okay that you know, it could be really either one and still be right, but the easiest thing to do would be what? Cosine. So I'd go with cosine. So is there a reflection? No, or not in the x-axis anyway. So we're going to do y equals, and this is pi, so it's in, I can't even see my red. Y equals cosine of what? Oh wait, what, I left my 3 off. 3 cosine, thank you. And then since my period is 4, it'd be 1/2 x, right? Because you take, to find the period, you take your normal period, which is 2, and you divide it by b, which is 1/2. And when you divide by 1/2, it's like multiplying by 2, and that's what your equation would look like. Does that make sense to you? We good with that? Yes? All right. Your amplitude on this one. What's the amplitude here? 2. Right? And what's my period? 8, right? Might seem weird, but it's 8. Now, do you know on this one whether you are in degrees or radians for sure? No. What are you more likely in? Not that it's, you really can't really decide either way. I mean, it could be degrees and be really, really small, bless you. Or it could be kind of numbers with radians. What did y'all use? Radians, most of you? Okay, that's what I figured. All right, so, well, and if you use degrees, it's not the end of the world. I mean, it'll be the same kind of process. It's okay, because I know it doesn't say. And that's why we said, you know, when you're given an equation, if it's x, we're going with radians. If it's theta, we're going with degrees, just so you don't have to question that. But when it's written like this and you're not told, you don't really know. So, all right, so I know that, or this looks like I would say sine would be easier. Would you agree with that? So we're going to do y equals, and, oh, well, showing it, or equals. Is there a reflection for sine? Yes. So it's going to be a negative, what? 2 times the sine, and then got to figure out what to do with that period. Well, you're looking for b. The normal period, which is 2 pi, divided by b, is going to equal, the absolute value of b really, is going to equal your period, which is 8. So if 2 pi divided by b is 8, then 2 pi divided by 8 has to be equal to b. So that means that b is what? Pi fourths. So pi fourths x. Okay, does that make sense to you? Good? What's the amplitude here? 3 again. Yes. And then this looks like a sine graph, I would say, that starts here. And what would your period be? 4. Okay. So then this is going to give me y equals, is there a reflection? No. So amplitude is 3 times, we'll go with sine. Could be a cosine with a translation. You understand that, right? It's just easier to do this. And then to get the period, or I'm sorry, we have the period. To get b, it's just 2 pi divided by 4, which gives you what? Pi halves. Does that help some? Yes? Okay. Good. Any questions on the graphs on the front, that's probably not, some of these didn't match. This was another case where my digital copies and my hard copies didn't always match. Did you have any questions? Yes, ma'am. Number 4? Okay, let's see, my graphs are actually here. Okay, so tell me, let me make sure this is match. What about number 4 made it, like, what's the question on number 4? Or what? This 3 right here? It's not the period, it's b. So to get the period, you have to do 2 pi divided by 3. Does that make sense to you? That's your period. It's 2 pi thirds. Okay. Anything else? All right. Okay, did you have a chance to look at the review, the yellow review? Because that's the one thing I was going to give you yesterday. Anybody have questions about it? Did you even look at it yet? And I had a request to look at tangent graphs. And we are going to do one of those. Let me find that. I guess I'm going to give you this. Oh, no, here it is. I'm going to give you a different version of what you just turned in. We're just going to do one graph on here, just that way you have the grid and we can do that. What's different on here from what you're turning into me is number 3. And we're going to look at number 3 together. Oh, sorry. Now, my plan yesterday, bless you, when I left here was that we were going to go ahead and test on Monday because there's really no reason to put it off. I think that it's simple enough, the test is not crazy hard, that we would be okay. But then I didn't get those graphs graded to give back to you, and I don't have a problem pushing it till Tuesday, and then what we were going to do Tuesday we can do Monday, just so that I don't want you to feel stressed about it because I haven't been here to explain things and because it might be taking a little bit longer to process, and I want you to be able to look over the stuff that you have turned in. So, you know, procrastinating on it doesn't really necessarily help anybody either, but would you feel better if we tested Tuesday instead of Monday? I mean, Monday tests kind of suck anyway, but I just want to... The yellow one? Yes. Okay. We'll do that then. We'll finish up reviewing today. I'm going to make sure you have stuff to work on. I will get some of the stuff handed back to you today. I'll get the rest of it graded, including what you turned in today, so that you can have it back with some feedback on it. Okay? Does that sound good? Does that make you feel a little bit better? Okay. Because, yeah, I mean, I can adjust grades all day long, and I don't have a problem doing that because I don't want you stressed out. But just because you have a decent grade in something doesn't mean you learned anything, and I understand that 100%. And I didn't give myself one of these, and I'm giving you the answers. Okay. Here we go. So we're going to look at this one. Now, on these, you can work these a couple of different ways. Remember, you can make the little charts, and you can do it that way, or you can just think about where the parent function is and what's happening with it. So I can actually, since I'm up here, do this in pencil. So for the tangent, right, you can make your little charts, and then the numbers kind of get weird. You get some like 5 pi 12ths and things like that, but those are really not that big of a deal to fix on here, okay? Instead of worrying about that, let's just go ahead. I'm going to leave the scale at pi halves, pi, 3 pi halves, and 2 pi. And that's something that you want to kind of decide maybe after you think about what's going on with that. And this might not be the best scale for all of them, but it works just fine on this one right here. When it really becomes a problem is when you have a horizontal compression and it like squeezes it too small, and then it's just really hard to, you know, fit everything in there. But there's not a compression, there's just a shift, so it's really not that bad. My parent function, I'm going to sketch it in lightly with pencil, and then I'm going to go back and do the rest with pen. But your parent function for tangent looks like this, and these are my asymptotes, and you can probably barely see them, but the asymptotes are at pi halves and 3 pi halves. I don't think you can even see them because I'm trying to do them white. And then we have it crosses the axis here at pi. Then because I know that I have a, what's the 4 represent? My amplitude. My amplitude is 4. I can't make 2 blocks be 1. I need to count, you know, actually count by ones up here. So when I'm doing my tangent for the parent function, it's halfway between these two at -1 and here at 1, and it looks like this. Okay. Whether you sketch it in or whether you have them just like written off to the side, I guess I need to make it darker so you can see it, but whether I just write it off to the side, you need to know where those key points are. Your key points are where the asymptotes are, and then these 3 points. So basically 5 points for each one of them. Okay? We all good with that? Okay, you've got to stop me and ask me questions. Ms. Rice said she gave me those. I thanked her for taking y'all and for grading the quizzes, and she said, you know, that y'all graded them yourselves. I'll give those back to you too. And anyway, she said your kids were real quiet, so I'm not sure. And I said, well, they're always quiet, so I never know if they get anything. But so you, they just look at me. I don't even know what to think about it. But all right, now we're going to start. So you just take each of these 5 points, or you know, the asymptotes included, and you decide what's happening with it in this graph. Okay, so with the x value of this first asymptote that's here at pi halves, it gets translated left or right? Left, pi thirds, right? Does the 4 do anything to my asymptote? No, because it stretches it vertically and it goes on forever anyway, right? Okay, so now we got to think about this pi thirds. Now, I could have made my scale to where this was all in pi thirds and maybe made that a little bit easier, but if you just think about what's happening in your first quadrant of your unit circle, this is 0, this is pi halves, right? Well, then this is pi sixths, pi fourths is in here, and then this is pi thirds, right? And what that is 0, 30, 60, 90, right? So this is 1/3 of the way, 2/3 of the way, all the way to pi halves. So if I'm going to move to the left pi thirds, I'm basically moving to the left 60 degrees, right? And this is 90. So right in here, I can go 2/3 of the way to the left. I mean, you can estimate that good enough where it's not just a big fat guess. I mean, this would be halfway. This would be about 2/3 to the left right there and make that point. And so my new asymptote is right here. Does that make sense to you? And again, if you wanted to change the scale because it made more sense to you, but sometimes you spend a long time trying to figure out the perfect scale, and you could have been done with a problem a long time ago and it still looked decent. I mean, if it looks like real crammed and you can't see anything, that's a different story. That's one reason why pencil's good. So then I can go ahead and do that with my other asymptote. I mean, I don't have to go in order. So this asymptote here, which is at 3 pi halves, it's also being translated left pi thirds, which is basically 60 degrees, which is 2/3 of that space. So it's going to end up here. And because there is no horizontal stretch or compression, the whole thing just gets shifted. It's not getting squished or stretched, so it all just shifts to the left. And so this point here, which is at pi 0, well, the x value is the only thing that gets changed because there's not a vertical shift. So I'm going to shift this point to the left 2/3, which is like right there. The fact that I multiplied by 4 means nothing, and there's not a vertical shift, so it's right there. Okay, we all good with that? Yes. What 4? Oh, that's because that 4 gets multiplied by the y values, right? And the y value right here is 0. So I do multiply, but 4 times 0 is 0. The amplitude. Yes. Yes, because well, that's part of it. But even on sine, like even here when let's see. We don't have one of these that doesn't have a shift. But let's say that this one right here didn't say +1. When I'm here at 0, 0, right? That's where my first point starts for sine. Well, when I take 0 and I multiply it by 2, I still get 0. And then when I take the y value of 0 and multiply it by 0.5, it's still 0. So that point doesn't move. It's more, right now, this has more to do with the fact that that the y value is 0 than it is that it's tangent. Does that make sense to you? The reason the amplitude doesn't work for tangent, like A is still important, is because that's a distance from the midline to a maximum or minimum, and tangent goes on to infinity up here, and so you can't find a maximum or minimum. Does that make sense to you? Okay. So here's where the 4 is going to come into play. We were here at, what's between pi halves and pi? What is it? 3 pi fourths, right? Okay, and we're going to move it to the left, how much? Pi thirds, right? And so you can think about, all right, so I'm going to take 3 pi fourths, and I'm going to subtract pi thirds, right? So I got to get common denominators. So that's going to be 9 pi twelfths minus 4 pi twelfths. What do you get? 5 pi twelfths, okay? So, do you need to mark off twelfths on your graph? Not necessarily, right? This would be the, but it's about how much? Yeah, it's about pi halves. It's right before pi halves, right? So it's like really, really close. So it's right, your x value is about right there. And it's close enough, because remember, you're just trying to get the same. It's halfway between these two, but it's about right there. And so what it was right here, I'm moving it over. Now the y value is at -1. What do I do with that -1? Multiply by 4. So it goes 1, 2, 3, 4. And there's your tangent. And then same thing over here. You're about halfway, which is about right here. So it's 1, 2, 3, 4. There's your tangent. And then you just repeat it over and over again. You can treat it the same way as you do the rest of them. If you want to get all of the ordered pairs out and mark stuff off on the graph, that's fine too. But if you focus too much on that, you get lost in all the points and you don't understand what's happening with the graphs and how it really is a lot easier than you make it out to be sometimes. It's more about understanding the transformations. Okay? We okay on that? Feel all right with that? Okay. I'm going to give you a little piece of paper, and we're going to do a little, it says quiz, it's not even going to be a quiz. We're going to do one together, and then I am going to give you one as a quiz, but again, it's not going to count as a quiz because I'm basically just going to give you 100 on it for participation because I don't want to stress you out because I didn't tell you we're having a quiz. And then, but you need to know what you can do on your own. That's what I want to make sure you can do. I had them in my hand. All right, well, I guess I'll do this one. So we'll just do this one together. I'm going to change something on here real quick, though. Oh, there's the other ones I was looking for. Oh, sorry. Can't count. All right, but we're going to change this. We'll go through, hopefully by now this is getting a little bit quicker for you and feeling a little bit better about it. Instead of vertical, this should say horizontal. Right there. Horizontal stretch or compression. And like, what is it? Not which one does it have. All right, so we're going to start with tangent here. And is there a reflection happening? No. So there's none. You can put a line or put none. Is there a horizontal stretch or compression? No. Horizontal there is not because that's something that's being multiplied by x. So the horizontal stretch or compression there is none. Amplitude. You sure about that? Okay. It's none, but a equals 1/4. Pay attention to tangent. You might want to, like when you have a tangent, like underline it because there's something. What else do you have to pay attention to with tangent? That's different. The period, right? Because the normal period for tangent is not 2 pi. What is it? Pi. And does the period get changed in this one? No. If there's not a horizontal stretch or compression, these two things go together because they both use B to get them, right? And so there is no B, which means your period is the normal period, which for tangent is pi. Is there a phase shift? It's phase shift is left or right. It's within the x, and see how there's not parentheses around this? So this is tangent of x minus 8. So there is no phase shift, which means it is 0. If it's in the parentheses. It's because there's no parentheses there. Basically, the parentheses that aren't there and don't necessarily need to be there are right there. So that makes this right here your vertical shift, right? So your vertical shift is what? -8. All right, look at the second one. Is there a reflection? No. Okay, so there's not a reflection. Horizontal stretch or compression? Okay, well, is there one? I'm sorry. Yes, okay, because there's something being multiplied by x. This is your b, right? And so is it 1/3? No, it's 3 because x lies, right? You do the opposite. Yeah, just 3. Just like if for the vertical shift, it's just, or like the amplitude, that's basically the horizontal, the vertical stretch or compression, and just put the number. But it's always positive. This number is always positive. It might be a fraction, but it's always positive. Amplitude, 2. Okay. What's the normal period for sine? 2 pi. So then we divide it by 1/3, which means we basically multiply it by this, which is 3, which gives you what? 6 pi. What? All right. What about the next one? All right, yeah. Is there a phase shift? Nope. So it is 0. A vertical shift? No, 0. All right, reflection for the next one. Is there one? Yes. In what? X-axis. Horizontal stretch or compression? None. And one technically would be an okay answer there, but none is fine too. It's just not 0. Amplitude, 1. Okay, and that's not a 0 or a none. The amplitude is 1 because that is a distance. All right, what's the period? 2 pi. Good. Is there a phase shift? 20. Good. Positive or negative? Positive. Okay, you should know that by now. And vertical shift is 7. Okay, we good? All right. So then the next one we've got, is there a reflection? No. Horizontal stretch or compression? 1/3. Good. Amplitude? 3. Period? 2 pi over 3. Good, because you got to take 2 pi. Dang it. And then phase shift? 15. Oh, 5. Dang it. Thank you. Yes. Here we have to, this is what she was asking about. You have to factor that out. And whether you literally do that or you just see it and know it, that's fine, but that's where it's coming from. That's 5. And then your vertical shift is 0. Okay. So, are we good with all that? Yes. Yes, ma'am. Yes, phase shift is the only one that really affects, because the number that you factor out is your is what you use for these two things, but you don't necessarily have to factor it out. But yes, you have to factor that if it's factorable. If there's something to factor out before you do the phase shift. Okay. And again, whether you physically do it or you just know that you kind of do it in your head. Oh, I have to take that and divide it by 3. It's the same thing. Okay. We good? Yes, ma'am. Okay. On the first one, the amplitude is none because tangent doesn't have an amplitude, but that A value that represents our amplitude is still important to us because we still have to use it, and it's a 1/4. But because we can't measure to the max and min, there's not technically an amplitude. Does that make sense? Good question.
So say, instead of us, it gives us the opposite, so it gives us the equation,
Mm-hmm.
and they have, like
Mm-hmm. Yes, absolutely. Well, if it, like for a sine or cosine, it wouldn't look like that. And honestly, the one worksheet I gave you, it actually said the tangent had an amplitude and gave you one, so you just go with it, I guess. But yeah, it would have to give you some value there if you're going to do that. Okay. All right, I'm going to give you another one of these. I want you to just, it shouldn't take that long. You're going to, once you do this on your own, not even with your neighbor, just what can you do 100% on your own while I pass out some of your homework or pass out something else to you. You can just hang on to that one. You can actually hang on to both of these so you have something to look at. Yeah, do it on your own. I'm not going to make you put up dividers, but I want you to, you need to know what you can do 100% on your own. The answers to this part, I think hopefully you can read it because it's in pencil. Do you, make sure you agree with me. Oh crap, what did I do? Would it be 4 pi? It's one time when it wasn't me that was wrong. Look at me. Yay for the teacher. Okay. Oh, yeah. Thank you. Here on this one, it should also say a equals 1/3. Yay, student. I know. It's sad when you have to celebrate that your teacher was right. Yeah, but here when it says none, it should be a equals 1/3 also. Yeah. All right. And see, I remembered on this one, I factored it out that time. I do know what I'm doing. All right. Any questions about those? Oh, yes, ma'am. Over 5. Yeah. When I made this, I didn't necessarily, I wasn't thinking that somebody else was going to have to read it, so I wasn't that careful or didn't even do it in pen. But, okay, do you feel okay with that stuff? You're good with it? Okay, awesome. Good, good, good. Now, I just want to real quick talk to you about some of the things that might be written on your paper. Now, I graded a couple of these, but then I have some student assistants 4th period, and they graded some of them as well. But let's just say on the beige one, for instance, for the amplitude here, where the answer is 1, some people put none. If you put none, they were not supposed to count it wrong. They were just supposed to write in the 1. So you might have some stuff written in red, but it doesn't necessarily mean that it's wrong. It was things that I knew that we hadn't really discussed a lot and I probably didn't make clear, so I wanted to fix and let you know what it was supposed to be. And same thing here, like with the phase shifts. Some of you like put none or maybe you'd put a slash or something. The phase shift is really 0, that type of thing. Just kind of fixing those little things for you. If it's wrong, there should straight up be an X on it. But if just something is written in, they were just kind of like basically you were right, but it's not in the right form type of thing. So it would help you to go over this. Do you have any questions on either the beige or the green one? I'm not sure that I have the white answer key up here. I might. I don't, but I could get it if I needed to. We good? Phase shift for number 8 is pi fourths. Because when you factor this out, when you have to divide pi halves by 2, that's the same as multiplying by 1/2. And just remember, the fractions, I know y'all still don't love fractions, but you're way better at them than you used to be. But when you're dividing by something, it's same as the multiplying by its reciprocal, and that can simplify things in your life like a lot. Okay? Okay. Are we good? Any questions at all? All right. So what I want to spend the rest of the time on then is we're going to look through, I'm going to click through this PowerPoint that apparently, right on. All right, so this says, what is the amplitude of the graph? Hang on, I got to put this over here too so I can write. So I think if I click on one of these, this desktop annotate, that's what I want. Because then I can write, yes, all right, okay, yeah. All right, what is the amplitude of the graph of this equation? 2. We all agree with that? Beautiful. Okay. I may not need to write for all of them, but. Oh, dang it. Uh-huh. Yes, you can keep both of those little ones. I don't need them back. It's fine. Okay, amplitude of this one. What is it? 2. Okay. The period of this graph, what is it? Pi. Because this is your b, so you take 2 pi divided by 2, it is pi. You don't even need the multiple choice. What's the period of this one? Pi. All right. Period of this. Pi over 2 or pi halves, good. The range of this function. Okay, now we haven't really talked about it in those terms, right? -2 to 2, right? You understand how to find that? Because it's the y values, and for a normal cosine function, it would be -1 to 1, right? And then this just has an amplitude, so it has a vertical stretch. What else would affect my range besides the amplitude? The shift. If there was a vertical shift, a horizontal shift is not going to affect it, but a vertical shift would. And you basically just do whatever you would do to points. You know, take your range and multiply it by 2, and then you add or subtract if you had to for a translation. All right, the maximum value. 3? You all agree with that? Yep. Equation of the graph. And notice how this says what is an equation. It doesn't say what is the equation because there's more options, but one option here. Now they're all the answers are sine, so let's just use some test-taking strategies here. Is there a reflection? Yes. So I can eliminate A and D pretty easily, right? And then there's a, yeah, what is it the X or the Y that gets compressed or stretched? It's the Y, so your answer is C. Does that make sense to you? You kind of go through it? Okay, good. I don't think any of these are too terribly crazy hard. So is that the same one? Can't tell the one. Okay. The graph of the equation y equals negative sine of x. So in your mind, you have to know what sine of x looks like, right? And then what does that negative do? It reflects it. Well, this is the sign without a reflection. This is also the sign with, well, this is the sign with a reflection, but is this the correct reflection? No. And then this would either be cosine or like sine with a horizontal shift, which we don't have, so your answer's D. Right? We good? See, I think you understand more of this than you think. All right, equation of this graph. Now, this is one where we don't see the whole thing, but that's okay. I mean, it can be a sine or a cosine. But if it's going to be a sine graph, what has to happen? A horizontal shift. Do the sine ones have horizontal shifts in them? No. Okay, so they can't be C or D. So then I know that there's not an amplitude here, but I got to figure out if it's 1/2 x or 2x. What is your period for this? 4 pi, because you can only see half of it, so that means it's got to keep going to get to 4 pi. So would it be A or B? A, because to get that 4 pi, you'd have to take 2 pi and divide it by one of those two, and it would be 2 pi divided by 1/2 to give you A. We good with that? Okay. Remember that 2 pi divided by B gives you the period, so 2 pi divided by the period gives you B. Works the same way. All right. What about this one? Well, they're all sine, okay? So let's take it a piece at a time. Is there a reflection? Yes. Is the amplitude something other than 1? Yes. What is the amplitude? 2. So is that enough on a multiple choice question to be able to find the right answer? Yeah, like you don't even have to understand the horizontal part of it. You need to because you can't always get away with it. But just knowing that the amplitude is 2 and that there was a reflection and it would have to be A. But then also your period would be, what would the period be? 4 pi, okay? Which means that you have to have the B of 1/2. We good? All right, so which equation is represented? Now the answer choices are all cosine. And what's the amplitude? 2, okay? And there's no shift or anything, but here, so that means it's either A or C, so I have to decide if it's 2 or 1/2 for my B. What would it be? 1/2. Okay, good. And it helps it when it's the same answers over and over again. I didn't realize that on this. Okay, which equation is represented? So they're all sine, all right? What's the amplitude? 1/2, okay? So that narrows it down to B and D. And then my period is what? My period is pi, because this is one cycle, right? So that means that the B has to be 2, and so your answer would be D. Okay, we good? I think y'all. Which equation? Blah, blah, blah. All right, so they're all sine. Good. What's the amplitude? 3. Okay. What's your period? Pi. Yeah, so pi, I'm close enough to pi. So your amplitude is 3, so it has to be one of these two, and your period is pi, so it has to be A. All right. Which one represents with a period of 4 pi? Be 1/2 would be A, right? Because this is the number that affects your period, and there you go. All right. All right. Tangent x minus pi halves. It's going to the right. So think about what is normally at pi halves. Like an asymptote, right? And that asymptote's going to get moved where? To the right, okay? And then at 0, what's normally at 0 for a tangent, for the parent function? Isn't this basically your parent function right here? Yes? So if you're going to translate, I mean, it gave you a picture of the parent function because your asymptote is usually right here at pi halves, and then the other one's right here. So this is your parent function. If you're going to move it to the right pi halves, this point's right here. Now you have a 0 at pi halves. That doesn't happen here because this is a stretch. It happens here, but so it does here. Which one of these two is the answer? D, because there's not a compression in there or a stretch. It's just a translation. Okay, does that make sense to you? You can just think about a few key points to be able to get you through. All right, what about tangent of 1/2 x? So what does that affect, the 1/2 x? The period, and it's a horizontal stretch or compression? Stretch. Yeah. So when you have this, okay, this is the parent function again. So that's good. It's in front of you. You don't have to really think about it or draw it. You just have to be able to understand that that's what it is. And this is a horizontal stretch, which means that this asymptote, instead of being at pi halves, is going to be here at pi, right? And so it gets stretched out like this. This was the translation, right? And this was the compression. B is your stretch. Okay, we good? What about this one? I'm going to hand this outline. Make sure you take, we still have a couple minutes, so I want to talk through these but before the bell rings on me. You can take the little half sheets. You can take all the papers except for what was due today. I'm going to give you this, which is very quick. It's a good another part of the review. We will test on Tuesday, so you're not stressed out, and I can give you your graph papers back. I'll make notes and stuff on them. Did anybody not get a yellow review? Okay. Yeah, nothing's made it to where it actually belongs this semester. All right, what do you think about 19? Because there's only like 3 more questions. I was hoping we could. There's a lot going on here, right? Okay, so the amplitude is 2. Well, they all have 2, so that stinks. For my parent function, at 0, y would be right here, but it gets translated pi halves which direction? To the right, and it gets reflected, right? Okay, so we don't have time to finish that. We'll look at these last 3. All right, have a great weekend. Email me or text me on Remind if you have questions. I will be happy to answer anything that you have. Try and get that pink one done by Monday. You can. It's quick. Do the pink one by Monday. That's what I want. That's what you need so that we can look at it and you're ready for your test. That's. I don't know how to get out of this. No. I'll just go through. I can't pause the video either, though. So. Okay. How am I supposed to pause this? Oh my gosh, what the heck am I supposed to do?